right, so thanks everybody for joining me before lunch. Hopefully everybody had some snacks beforehand. So we are going to talk about securing the Kubernetes dashboard in the command line world, or how I learned to fall in love with the Kubernetes dashboard. Real quick, who am I before we get into the fun stuff? My name is Marc Boorshtein. I'm the CTO of Tremolo Security. I've been doing identity management for 20 plus years. You name an industry and a product, there's a pretty good chance I've implemented it or worked on it. I've been working with Kubernetes since 2015. RBAC, so I think that's 1.3 was when that came out. If you are in the Kubernetes Slack and you're asking RBAC questions, or you're asking authentication questions, pretty good chance you've heard from me. And then I'm also the co-author of Kubernetes and Enterprise Guide 2nd edition. So enough about me. Let's talk about what we're going to talk about. So our agenda. So the first thing we're going to do is talk about why dashboards are good. Sometimes dashboards have a bit of a bad rep in this business. So I want to talk about why they're a good thing, why you should think about them inside of your deployments. And then we'll talk about why they got a bit of a bad rap. What are the issues with deploying dashboards? What are the anti-patterns that you should avoid? How to do it right? And then we're going to hop into some demos. So dashboards are good. So I've got Darth Vader here saying, hey, let's go ahead and manage this cluster with our dashboards. A lot of times we like to identify ourselves with the rebels, we're fighting the machine. But when you're talking about enterprises and the machine that is enterprises, they like their dashboards. And a part of the big reason for that is because you just can't get as much information as quickly from a CLI as you can from a dashboard. It gives you very quick access to a lot of information that just isn't available as quickly from your kube control CLI. So here we got a picture of the venerable Kubernetes dashboard. It's got to be at least 10 years old at this point. And if you look at it, look at how much information you got here, right? You know what's running, where your cron jobs are. If we scroll down, we'd see what pods are running, what labels there are, all very quickly. If there were problems, we'd see a big red angry mark here. There's also utilities here. So for instance, if you want to be able to manually launch a cron job to run, typical processes for support, you can do that. If you need to manually delete pods, you can do that. Heck, if you want to manually deploy something, you could even do that. So the great thing about this dashboard is it's giving you a lot of power without having to be tied to the kube control CLI. So another one I really love to show off is Kiali. Kiali is the dashboard for Istio, open source dashboard for Istio, that is. And so here we're taking a look at Open Unison and what it looks like internally. And you see all the different graphs, you see the lines, you see the vertices. So again, you're seeing all the information about what your application is doing without having to go to each individual API. You're not going to the individual services. You're not looking at, different endpoints. You're just getting that snapshot very, very quickly. So Luke's here training on Dagobah to become a cloud native Jedi, and he's asking Yoda, are dashboards better? Is it better to use a dashboard than kube control? And the reply is no, it's easier, more seductive. And so, there are a lot of people who think the Republic fell because of the Jedi being unable to adapt to the way people react, and part of that is they just didn't want to use Kubernetes dashboard. So the reliance on kube control CLI, it's great, don't get me wrong, I use it every day, but just because it's easy doesn't mean it's bad, right? Like, we tend sometimes to feel good about how hard the things we are doing, but sometimes we can also cut ourselves some slack and do things the easy way. But this is, of course, is a danger too, right? That's a double-edged sword. It's easy, but it's easy, right? And so that can lead to a lot of problems. And this is the one that comes up the most. In 2018, Tesla launch their dashboards in a very secure way called non-standard ports. And amazingly, someone found them, got into the dashboard. Once they got into the dashboard, they had access to the pods. Now, they actually didn't care about the Kubernetes clusters themselves, but these pods were running on a cloud. And because the pods themselves weren't particularly well set up, the attackers were able to get into the cloud access keys on the node that they were then able to use to launch crypto miners. So, this is one way to use dashboards for fun and profit, not the one we want to focus on, though. How did this happen, right? What did Tesla do, and why is this often so often brought up as an issue? Well, there's a fundamental difference between the way web applications work and the way the kube control process works and the way APIs work. APIs, you make a request. That request has, this kind of finite package of a body. It has headers. It might have a certificate associated with it. And that's it. You're done. Right? Like there's no session management. Your token should hopefully be short-lived. But when all is said and done, it's just one transaction. Whereas web applications, you have a session that you need to manage. And session management is really, really hard. It's really easy to do wrong. It's really easy to mess up. And the way most dashboards do it is kind of easy to break. And so when we talk about the security of the dashboard, we're not really talking about the security of the dashboard so much as we're talking about the security of how you're deploying it, what you're using for your session management. So we're going to go back in time to a conversation that Anakin had with Padme. And, there is this misconception that Anakin's fall to the dark side happened because Palpatine manipulated events across the galaxy in order to separate him from the warmth of his family, when really what it was one, he didn't listen to his wife, and two, because he didn't listen to his wife in rejecting these anti-patterns, Palpatine was able to hack his dashboards. And so kind of going through what these different anti-patterns are, like Tesla did, running it on alternate ports, you're not fooling anybody. Running with a privileged service account. And when you're talking about a dashboard, almost any permissions you give it can be considered privileged because you're in Kubernetes, right? Like even just read-only access to things like deployments, that's intel about an environment. People might put things inside those manifests that they shouldn't. So really any kind of permissions given to a service account in a dashboard is in fact privileged. Which means that if somebody gets a hold of that, they can now access your API server from outside of your dashboard. Avoid an unauthenticated ingress. So what I mean by that is there are several dashboards out there that try to take on authentication by themselves. And they say, okay, come get me. I'll go ahead and authenticate you. But the problem is that if there's any bug in that authentication process, the call is already coming from inside the house to switch movie genres, right? Like if the authentication process is broken and I can break into that app to get to that service account, it doesn't matter if I'm authenticated or not. So having an unauthenticated ingress into your dashboard means that you're now opening up the doors and saying, well, hopefully everything's okay. This brings us to the next question of how most dashboards actually do logins. You look at the docs for pretty much any dashboard. What they tell you to do as the secure way to do it out of the box is generate a service account, generate a token, use that token to access your dashboard. Those tokens are generally very long-lived, if not immortal, because those tokens don't have. If you generate a token with your service account that is persisted in the API server, there is no expiration. You've got to delete the service account in order to rotate it. And then what they then do at that point is if you take that token and you use it to log in, they just encrypt it and shove it in a cookie. They don't rotate it. They don't refresh it. So you now have this very static key. It's basically just a more complicated API key. And so that also becomes an anti-pattern. And you're probably starting to see a pattern here of anti-patterns, of identity-focused problems with bad deployments of dashboards. Next comes up is static session management. Are the keys rotatable? Can you delete the sessions? Can you log a user out and stop them from being able to access the system once they've gotten in the front door? The problem with an encrypted cookie, as an example, is there's nothing that ties that encrypted cookie to something that you can destroy. So if I have a long-lived token and I need to get walked out the door, and I have the cookie that token was created, it doesn't matter that I can't decrypt it. You can't stop me from using it. Right? So you need something that knows how to manage that session. A common pattern within dashboards is to use caches. You know, it can get expensive talking to the API server for everything to get all that data. So they pull in caches internally to be able to build up. So that way when requests are made, it might not be immediate, but it's at least, you know, relatively fresh. The problem with that approach is you're now no longer using the API server as your authorization engine. So you need to be able to do subject access reviews and say, hey, before I let this user access this screen or access this information, I need to still ask the API server, is the user allowed to do it? And then finally, single factor weak authentication. Google did a study a few years ago. 95% of phishing attacks are, you know, even the worst MFA in the world is still going to stop it, right? I've got a meme I've been using lately with the aliens where I say pass keys, and that's a whole other conversation. But please, no single factor authentication when accessing the dashboard. You shouldn't have single factor authentication when accessing kube control either. So those are the anti-patterns to avoid. And of course, Anakin didn't listen to Padme. He got burned by it and ended up becoming Darth Vader. So now that he's a Dark Lord of the Sith, he works with the machine that is the Empire to get a corporately approved security model for your dashboards. And they all look basically the same, to be honest. You've got your user interface. Your user interface is usually going to be some kind of JavaScript framework. Like, don't worry about that one too much. And then you have a reverse proxy. I am a big fan of having a reverse proxy between you and your dashboards. The reason is that, like I was talking about before with unauthenticated ingress, you want to stop a potential attacker as soon as possible. And while you might be relying upon things like MFA and strong passwords to keep them from getting in the front door, if your authentication starts at a reverse proxy and not at the dashboard itself, that means that a bug inside of the dashboard that would expose anonymous access to the service account token, user won't even get there. So it's important to be able to have that layer in place. Then you get to your middle tier, and your middle tier should do as little as possible to the identity. It should pass it through, whether you're talking about managed cluster using OpenID Connect, or like we're going to show here, cloud hosted cluster. We're running our cluster on Civo, so we're using impersonating proxy to be able to authenticate access into our dashboards. And then finally, the middle tier of the dashboard, it's passing on the user info object, which is, you know, the header and potentially impersonation headers onto the API server. And now the API server can use its own authentication authorization systems in order to figure out should the user be able to access this API. So Darth Vader's grandson, Kylo, falls to the dark side. And, people think that this confrontation with Han Solo was about, whether or not he had the strength to face the dark side. No, he was really worried about whether or not he wanted to go through the pain of setting up a secure reverse proxy to authenticate into his dashboards. So you're going to find that the patterns that you want to use kind of mirror the anti-patterns, right? So let the reverse proxy do the work for you. Whether you're going to use, we're going to show off Open Unison here, OAuth 2 proxy, Kubo OIDC proxy, whatever it is, let the reverse proxy do the work for you. It's going to do a better job of session management than you will ever hope to do on your own, especially as a dashboard developer. Dashboards are hard enough to build correctly. Let something else do the security work. Once you've got that reverse proxy in place, make sure to use network policies to limit how network access gets to your dashboard. If you've got a Kubernetes dashboard in place and you're going to require access through a reverse proxy, put in a network policy that stops access from anywhere else in the cluster. So that way you're making sure that the information comes through that reverse proxy. Use impersonation with managed clusters. So one of the difficulties of running a dashboard on a managed cluster in this way is that most managed clusters, you can't get to those API server configurations, right? You can't configure OIDC. 1.29, I think, is alpha of the new authentication configuration management system. So it's no longer command line parameters. It's an object, but it's a static object. It's not something that's sitting in the API server. It's something that sits on each individual control plane node. So it'll be interesting to see how that gets adopted. But use impersonation. Use kubeIDC proxy. Pinniped has its own impersonating proxy. I think Rancher has a built-in impersonating proxy. Use a impersonating proxy with your cloud managed clusters. That way you're able to convey that identity information down to your dashboard. And when you do that, make sure you're using short-lived tokens. Starting with 1.24, the default with Kubernetes was to assign a expiration of, I think, an hour to tokens. You can make that even shorter. So I'm going to show off here how we do it with 10 minutes. Shorter the token lifetime, the less likely that a lost token is going to be used against you. Notice I didn't say it's the less likely you're going to lose the token, because I can promise you, you're going to lose the token at some point. Somebody's going to log it improperly, which is what I'm going to be doing here. Somebody is going to check it in by accident. Somebody's going to do something they shouldn't. There's going to be a bug. So this protects you. And then make sure that there's a way to log out. If you have long-lived session management, if you have sessions that have no way to be destroyed, that means you now have a continuous breach until that session is somehow no longer valid. And so having a mechanism to be able to break that session, even if it's after a couple of minutes, is still a way to mitigate. And then I don't know how I skipped this one because I beat this one to death. Multi-factor authentication. Going to be the easiest way to lock down access to your infrastructure. So yeah. So what apps are doing it right? So these are the apps I have experience with. There might be more. I'm not saying that this is in any way exhaustive. So Kubernetes dashboard works with both on-prem and managed impersonation. One of the things that are the quirks, and there's actually some work being done to make this a little bit easier, is you need to be able to list namespace in order to use the Kubernetes dashboard in a multi-tenant environment. Kubernetes, if you have, there's no way to say, show me what I have access to. You have to just ask for all of them or ask for one of them. So list and get have very similar properties, and it can make for a little bit of weirdness there. CLI also supports both on-prem and managed impersonation. They're having a few issues with multi-tenancy right now that I'm working with them on. We discovered that their internal cache is doing a validation on whether or not you can get the namespace before it shows you all the information in the namespace, except namespaces are cluster objects. They're not namespaced objects. And that subtlety means that that permission standard doesn't actually work. Tecton CD also supports both. I don't do a lot of work with Tecton, so I don't know if there are some quirks that I've missed, to be honest. KubeApps is from VMware. It's kind of a web-based UI for Helm, and it only works, unfortunately, with on-prem OIDC implementations. I've got a customer that's using it. They love it. Have talked to them about maybe adding impersonation support. But there are probably other apps too. When you go and you look at a dashboard, because there are several dashboards out there, the important thing is ask, do you support impersonation? Do you support a reverse proxy model? Are you passing through the identity? Make sure you're going through that checklist of the best practices. So let's do some demos. Let's see what this looks like. And what's going to be interesting about this is, first thing I'm going to do is I'm going to log in. Yeah. So I'm going to log into my Civo instance. Maybe I'm not. Let's see here. Have the gods maybe frowned on me? Civo. Let's try this again. Kai, what'd you guys do?
Right. But yeah, I might not be able to fix it right now.
Let's try it one more time. Okay, so clearly the gods are not shining down on me today. So one thing I will point out, I did have this set up before, is that I'm going to try one more thing, actually. Let's try this. Sometimes just switching the browser. No, go away, Firefox. K2U dot Civo now. Let's see here. So anyway, what I'm going to point out is this is an example of the token that comes in through impersonation. So when a impersonating proxy is talking down to the API server, it's not the identity of the user that's sending, it's actually the identity of the proxy. And so the identity of the proxy here is, let's make this a little bit bigger so you can see here. So this is the namespace of Open Unison. Open Unison is the open source project that Tremolo has built. And so that's the identity of our service account. And what I'll point out here is that it was initiated at 10 o'clock and it only lasts for 10 minutes, right? So that's one of those patterns we were talking about, is make sure that you have short-lived tokens in there. Now, as luck would have it, I talked a lot longer than I thought I was going to, so probably the demo wouldn't have had time anyway. So I'm going to say thank you. No, not share. I know technology. If you are interested in learning more about Open Unison and actually deploying this in a sane way, go ahead and check us out. Open Unison, github.io, 100% open source. If you would like to read about the book, Kubernetes Enterprise Guide 2nd edition, available on Amazon. The 3rd edition will be coming out in August. We're going to have lots of new stuff. Secrets, virtual clusters, logging, monitoring, etc. And then if you want to get into the nitty gritty of how to do this without Open Unison, I've got a write-up here on how to do it with a lot of different identity providers using a combination of OAuth 2 proxy and OIDC, KubeOIDC proxy. So with that, I will open it up to questions. All right. Well, thank you very much. Oh, wait, we got one.
I don't know if you have a good example of command line tool doing MFA.
So the question was, is there an example of a command line tool doing MFA authentication? Yes. So there are a couple of different ways that works. One way, which is kind of the more standard-ish way, I guess, as you would call it, is OIDC has a profile called oh gosh, thank you. And so device flow login, and where that's where, like, if you've ever logged into like your Roku or something, it says go to this website and put in these this code, right? So that's one option. Open Unison, we actually have a plugin for kube control that fires all that off for you, so you don't have to do that. And so that's how you manage to separate the command line from the web browser. The other way Open Unison does it is we'll just generate your kube control configuration once you're logged in, and then let kube control handle the token refresh.
So there's been a lot of interesting startups in the area of authorization. For example, there's one here, I forgot their name.
Cerbos?
Cerbos, thank you. And also we have Styra with OPA. I'm curious on your thought about, is there any sign that dashboards might actually integrate with these authorization frameworks so we can get more granular control?
So great question. So the question was, is the dashboard, so I assume you mean Kubernetes dashboard,
Right.
going to integrate with OPA to get finer grained controls? I don't know that the Kubernetes dashboard itself will, but that said, being able to leverage an external authorization engine is a great idea in general, to be able to offload that. But that'd be a really application dependent approach. So I have not seen any dashboards for Kubernetes that do it, but I think it would be a great idea. All right, let's go get some lunch. Thank you, everybody.